Alright folks, we are going to review some adding and subtracting of rationals, which really just means we're going to be adding and subtracting fractions. However, pretty much all of these fractions are going to have some type of variable in it. Alright, so there are 4 basic steps to adding or subtracting rationals. And very first, you must have a common denominator in order to add or subtract rationals. So what that means is if you've got fractions that you're adding or subtracting, you may have to factor. Alright, if there's variables involved, you may have to factor to find a common denominator. Meaning the values on the bottom of your fraction are the same. Alright, so factor to figure out what they have in common and what they need in order to be in common. Alright, step 2 is once you know what your common denominator should be, you need to multiply. You need to multiply to the numerator and denominator to create your common denominator. Alright? So first you factor to figure out what it should be, then multiply to make it happen. Alright? If we're subtracting fractions rather than adding, then that means we need to distribute the negative sign to everything in the following numerator. Because when you're subtracting, that minus sign is basically just changing the sign of everything behind it in the parentheses. Alright, also real quick, I'm going to highlight we need to multiply the numerator and the denominator by whatever it is that we need to in order to create a common denominator. Alright, once you've got that, that's typically what takes the most work, is this step 2. Step 3, after that, you combine like terms in the numerator. Once you've got your common denominator, you can kind of forget about your denominator for a little bit and just look at your numerator. Combine like terms in your numerator. And then your final step is to write your answer as a simplified fraction. Simplified. Meaning if there's anything that can cancel it out. Alright? If not, that's okay. So let's take a look at some examples, walking through these steps, and then you guys should be good to go and take a look at that assignment on Google Classroom. Alright? So here, our first example, we've got these examples. This first example has the steps underneath it. So our very first step is to find our common denominator. Alright, do these fractions have anything in common in the denominator? I mean, they both have x's, but those x's are tied to some other number. So here, our common denominator, I'm going to zoom this in a little bit. These don't really have anything in common. So what we're going to do is list our common denominator. One of our fraction has x minus 1, and that cannot be factored. Alright? Our other fraction has x plus 2 in the denominator. So this is going to be our common denominator. Both of these fractions need to have x minus 1 and x plus 2 in the bottom. Alright? So here's how we make that happen. This is where we multiply both the numerator and the denominator by what it needs in order to get our common. Alright? So our initial problem is this, I'll write it way up here, because sometimes we need a little bit more space. 6 over x minus 1 plus 9 over x plus 2. Alright. What is our first denominator missing? It's missing the x plus 2. So we're going to multiply both the numerator, the top, and the bottom by x plus 2 because that's what it's missing. Alright? What is our second fraction missing? It's missing the x minus 1 in our denominator. So I'm going to multiply the top and the bottom by x minus 1. Alright? So, there we go. We've multiplied to get our common denominator. Now we need to distribute this out. So then in step 3 we can combine like terms. Alright? So, we are going to distribute this 6 to the x and to the 2. Alright? So, that's going to give us 6x plus 12. Alright? And then I'll go ahead and put this over our x plus 2 and our x minus 1. Alright? On the other fraction, we're going to distribute this 9, and we're going to get 9x minus 9. Alright, the reason I only multiplied on the numerator is because we can leave our denominator in factored form. It's just less work for us, and it's a lot easier to just leave it this way. But we do have to distribute and multiply in the numerator so that we can combine like terms in step 3. Alright? So, now what we would do, this addition sign in front means that we can just put all this together and say that we have 6x plus 12 plus 9x minus 9, because plus 9x plus a positive and plus a negative is going to stay negative, all over this x minus 2, that's x plus 2, x minus 1. When we combine like terms, this 6 and this 9x, 6x and 9x are like terms, and then we have this positive 12 and this negative 9 that are like terms. So, 6x plus 9x is 15x, and then 12 minus 9 is a positive 3. And this is all over our x plus 2, x minus 1. Alright? So really, this is our end result. For our final answer, remember, we want to put our fraction in the most simplified form. So, if I can cancel anything, I want to. Now, I can factor my numerator here, because what do 15 and 3 both have in common? They both have a 3 in common. If I take 3 out of 15, I'm going to be left with a 5x, because 3 times 5 is 15. If I take 3 out of the 3, I'm going to be left with a 1. Alright, and then our denominator is going to stay the same. Now, is there anything that cancels? No, but we do have to check for it, alright? So, this would be our final answer. Okay, we're going to take a look at just a few examples here, and then you guys should be good. And if you have any questions, there's lots of resources available that you guys can take a look at or ask questions to. So let's take a look at let's see here. Let's take a look at number 3. We'll do maybe We'll start with number 3 and then kind of bounce around to some different ones. Alright? So, number 3 I chose because it's a subtraction problem. Alright, so first thing that we want to do is get the common denominator. But in order to get the common denominator, remember we might have to factor. Alright, so this denominator, 2x minus 4, can factor by 2. They both have a 2 in common, which is going to give us just x minus 2 as our denominator there, instead of 2x minus 4. Because if we multiplied this back out, we would get 2x minus 4. This x squared minus 4, remember that's a difference of squares. Both of these are perfect squares, so this one is going to factor into x plus 2 and x minus 2. Alright, instead of this x squared minus 4. So, for our common denominator here, what is this first fraction have? The 2 and the x minus 2. What does this second fraction have? Well, it also has an x minus 2, so they have that in common, but it also has an x plus 2. So this is going to be our common denominator. This is what all of our denominator needs. Well, what is this first one missing? It's missing the x plus 2, so that's what I'm going to multiply on both the top and the bottom. The x plus 2. Alright, what is this second one missing? It has an x plus 2 and it has an x minus 2, but it's missing just the number 2. Alright, so I'm going to multiply both the top and the bottom by just the number 2. Alright, so now our next step is to distribute. So what we're going to get is x times x is x squared. 2 times x is plus 2x. Then we have this minus sign. 5 times 2 is 10, but instead of saying plus 10, because of our minus sign right here, that means it's going to be minus 10. And then our denominator is now our common denominator. They all have a 2, they all have an x minus 2, and they all have an x plus 2. Alright? And now what we would do is we would combine like terms. Is there anything that we can combine in our numerator? No, there's not. So we would write our answer in simplified form, if we can simplify. So what I'm going to do is this numerator here, we're going to big X this to see if it can factor. Alright, so we're going to see if we can factor by putting negative 10 up top, and then b, so 2 goes on the bottom. Is there anything that multiplies to negative 10 and adds to 2? This is not factorable. Alright, so this would be our final answer. Alright, sometimes it is that simple. Most of the time it is that simple. A lot of times our brains just like to complicate things. Alright, if we were to take a look at number 5, underneath that, for our common denominator here, something that I see is I see the number 2 in 2 of these fractions, and I see an x in 2 of these fractions, and nothing else. So my common denominator is going to be a 2 and an x. What is this first fraction missing? It's missing a 2. So I'm going to multiply both the top and the bottom by the number 2. Is this middle fraction missing anything? No, it's not. It's got 2x already. This last fraction is missing an x, so I'm going to multiply by x on both the top and the bottom on that last fraction. Alright, so second step, we distribute. This 2 distributes to that 3. This 1 distributes to this x. Alright, so we're going to get 6. Then I have a minus sign, which changes all of these. It's going to change that plus to a minus. This minus is going to change this positive 1 to a negative 1. Alright, so this is going to be minus x minus 7, and then minus 1 times x is 1x. Alright, and this is all over our common denominator of 2x. Now we combine like terms, so we have some x's here that we can combine, and we have a 6 and a negative 7 that we can combine. So we'll do our x's first. Negative x and negative x, 2 negatives being added together, that's going to negative 1 and negative 1. That's going to give us a negative 2x, and then 6 minus 7, going to be minus 1, all over 2x. Alright, and this would be our final answer, because we can't factor anything here other than a negative. If we factored out a negative, we would get a negative on the outside here, and we would get 2x plus 1 over 2x. Alright, that would be our final answer. Alright, now we cannot cancel out this 2x and this 2x because they are not the same. This 2x has a plus 1 that's tagged along with it. It's stuck with that plus 1, while this other one is free. It doesn't have anything attached to it. Since they're not identical, we cannot cancel them out. Alright, we'll take a look at one more here. Alright, let's take a look at number 6. Alright, so with number 6, first thing that we're going to have to do is factor our denominators. Alright, so I want to know what multiplies, we're going to use the big X here, what multiplies to 4 and adds to 4. Oh, 2 and 2, right? Both positive. So this is really going to be x plus 2 and x plus 2 for that one. Alright? In our other denominator here, we have x squared minus 4. Remember, that's a perfect square. That's the difference of squares. So this one is going to be x plus 2 and x minus 2. Alright? So, for our common denominator here, I'll do it in the red since it's a different color. For our common denominator on this one, they both have an x plus 2 in common, but this one has a second x plus 2. So we're also going to need another x plus 2, and our other fraction has an x minus 2. So this is what we need to see in our denominators. Alright? So in our first fraction, we have two x plus 2's, but we're missing the x minus 2. So that's what I'm going to multiply. Oh, that needs to be a minus. Minus 2 x minus 2 on the top and the bottom. In our second fraction, we have one x plus 2, and we have the x minus 2, but we're missing a second x plus 2. So that's what we need to multiply by on the top and the bottom to make these all the same. Alright. So, what we need to do here, I'm going to go ahead and write this out so we can see this a little better. We're going to have x minus 2, x plus 1, minus 6x plus 2. That's essentially what we have. And then it's all over our common denominator now of x plus 2, x plus 2, and x minus 2. Okay, so second step, we want to distribute. Alright, here at the beginning, we're going to have to FOIL or use the box to distribute here. Remember, first, outer, inner, last is that FOIL distribute method. So we're going to get x squared plus x minus 2x minus 2. And then check this out. We have a negative 6. We have a negative 6 here. So that negative 6 goes to the parentheses. Negative 6 times x is going to be a negative 6x. Negative 6 times 2 is going to be a negative 12. Alright? This is all over our common denominator. And now we combine like terms. I don't have anything that combines with the x squared, but I do have several x's that I can combine. And then I've got some whole numbers that I can combine, okay, that don't have variables with them. So when we combine here, we're going to get nothing combined with the x squared. X minus 2x is negative x. Minus 6 minus 6x should give us a negative 7x. Alright, then we've got negative 2 minus 12 is going to give us a negative 14. All over x plus 2, x plus 2, x minus 2. Now remember, check to see if we can factor this. Alright? So we're going to big X this, put negative 14 on top, negative 7 on the bottom. Is there anything that multiplies to negative 14 and adds to negative 7? No, there is not. This is not factorable by the big X. Okay, we wouldn't have real zeros. So, this would be our final answer. Alright, hopefully that was helpful. Again, if you need more examples, let me know or look online. We have done these notes already, so you guys should have other examples in your notes. And I'll see you next time.